All right, these two application questions this is honors, okay? So this is going to be honors level applications of a 30, 60, 90 triangle. And that's kind of what we've been doing the past few days, is we've really been amping up the rigor in the questions that we've been doing. And we're still going to keep doing questions that are challenging like this. So I'm going to skip these first few up here. They're actually pretty simple. They're just basic 30, 60, 90s. You just draw a diagram. But I'm going to go to these two questions down here. And these two questions, year after year, just happen to show up on our quiz. I mean, lucky for you, you're virtual, so you can always go back and reference this video. But you should be watching this video first and then following along. So here's the first scenario. It says, after heavy winds damage a house, workers place a 6-meter brace against the side of the house at a 45-degree angle. Now, I don't see a house, so that's going to be the first thing I have to draw. Then, at the same spot, they placed a second longer brace to make a 30-degree angle with the side of the house. So this 45-degree angle with the house and this 30-degree angle with the house means that the house is here, and we're just going to pretend the house doesn't have a roof, or else I would be in the problem. I guess I got to go down here. Okay, so now let's figure out what's going on. This house is falling over, okay? Maybe it's like leaning this way. So in order to have the house standing straight back up again, they're going to place these braces against them and hope that the house now will not fall towards the braces. So they just conveniently place these braces at a 45 and a 30-degree angle. They must have known the lesson that we were doing. So they first place a 6-meter brace. Now you have to think about a brace. The brace is what's on the angle. So that's going to be angled against the house so that it does not fall down. So this, from here to here, is going to be 6. And that's the hardest part of this problem, is figuring out where the brace is. Then at the same spot, so in the same spot in the ground, imagine that they just like hammered these into the ground here. They place a second longer brace, and it makes a 30-degree angle with the side of the house, but they don't tell us how long the longer brace is. That's question B. All right, so that's the first question. So now it wants to know, how far away from the house are the braces placed on the ground? So the ground is down here. This is the ground. So the first thing I'm going to do is I'm going to take this triangle that is just conveniently 45, 45, 90, and it has a hypotenuse of 6. So the first thing I'm going to do is use my 45, 45, 90 rules and divide 6 by root 2, which is 3 root 2. So that's how far away it is from the ground. That's obviously the exact answer. We are going to use decimals for the first time now, because you wouldn't talk to somebody and say it's 3 root 2 meters away. You can't really conceptualize what 3 root 2 is. But that's the exact answer for now. That also means that from here to here is 3 roots of 2, because it's a 45, 45, 90. Then it wants to know, how long is the longer brace? Remember, the longer brace was this one. And if you look at this one, you'll notice that there are 3 triangles here. But you actually need the one that involves the 90 again. So now I'm going to take out this 30, 60, 90. Remember, only this was 45. So that means that this has to be 15. And that has to be 60. And the short leg across from 30 is 3 root 2. So now you have the short leg. I'm just going to go ahead and get all of the sides. That says 2. 3 root 2. I'm going to go ahead and get all of the sides. So let me just get the hypotenuse first because that's easiest. I'm just going to double this and get 6 root 2. And then to get the long leg, remember I'm going to do 3 root 2 times root 3. And I'll get 3 root 6. So that means that the entire house is 3 root 6. The brace itself is 6 root 2. So how long is the longer brace? It is 6 root 2. And these are meters. Okay. Last question, and we're going to get the exact answer, is how much higher on the house does the longer brace reach than the shorter brace? Well, the longer brace is reaching the height of the entire house. The shorter brace is only reaching 3 root 2 up the house. Now, normally we would just leave it like this. I'm going to say this is the exact answer. So on a quiz or a test or whatever, you would put this in. But just know that on the next problem, we are going to actually subtract these and get a decimal answer, just so that we could like conceptualize how tall something is. But I'm going to leave all these answers in exact form since that's what we have been doing. Okay, next one. This one's exciting. Pause. Just pause for a second. If I said that I drove at a rate of 25 miles per hour, and I wanted to know how long would it take me, or how far would I drive if I drove for a 3-hour trip? How many miles would I drive for a 3-hour trip? If I'm going 25 miles per hour and I'm going to drive for 3 hours, you should recognize that I would drive 75 miles. Let's talk about this as a proportion. 25 miles per every 1 hour. I'm taking a 3-hour road trip. How many miles would that be? So you can see I just did 25 times 3. This just is x times 1, so that's easy. And you get 75 miles. We're going to need that. All right, so here we go. No pictures. We have to draw a picture. A conveyor belt carries bales of hay from the ground to the barn loft 24 feet above the ground. So on the ground, they're going to load up these bales of hay. They're going to put them on a conveyor belt, and it's going to go into the loft of a barn. The loft is like a little attic. So let's just read this again. The conveyor belt carries bales of hay from the ground to the barn loft 24 feet above the ground. So this is telling you that the barn loft is 24 feet above the ground. The belt makes a 60-degree angle with the ground. So again, here's the ground, not drawn to scale. The belt and the ground make a 60-degree angle. Again, very convenient. Okay, how far does the bale of hay travel from one end of the conveyor belt to the other? So from here to here, what is the distance? Well, it's a 30, 60, 90 triangle, so I'm going to take this out real quick. That's 60, and this is 24. So really, you just have the long leg. I'm going to take the long leg and divide it by root 3, which is 8 root 3. So that's how long this conveyor belt is. Okay, and that's in feet. Okay. The conveyor belt moves at 100 feet per minute. How long will it take? That's very fast. Is it? Yeah, 100 feet in a minute. Maybe not that fast. That's not that fast. The conveyor belt moves 100 feet per minute. How long will it take for the bale of hay to go from the ground to the loft to find the answer to the nearest hundredth? Okay, great. I'm going to write this as a proportion. 100 feet for every 1 minute. 100 feet per every 1 minute. Now, this is only traveling 8√3 feet. So you should be thinking to yourself that it's going to be less than 1 minute. So here's where I'm going to say, let's get this answer as a decimal. Oh, I need a calculator. Hold on. So if I put in the calculator 8√3, the approximate distance of 8√3 feet is about 13.86 feet. Okay, so that is way less than 100. So our time should actually be way less than 1 minute. So I'm trying to figure out how long it would take. So I'm going to cross multiply. That's just 13.86 equals 100x. And then I'm going to divide by 100, which is going to be 0.1386. All right, it's going to get crazy. 0.1386 minutes. Now, I know that the question says, find the answer to the nearest hundredth of a minute. But let's just put this in a context that we can understand, because I can't understand what 0.1386 of a minute is. But I can say that I know a minute is 60 seconds, and maybe I can understand seconds better. So if I take 0.1386 of 60 seconds, I'm just converting 1 minute to 60 seconds in my head. Now I can say 0.1386 times 60. I understand what 8.316 seconds are. Like, I can understand that. I can count to 8 and be like, oh, that was 8 seconds. So sometimes, I mean, I would probably just change the way that this question is worded, but sometimes it's better to just get that representation so you understand the question. So those were those two questions. I'm also going to leave you this worksheet, and I'm going to make a separate video that goes over these answers for this worksheet. But again, this is a very good, rigorous worksheet here.